Hello, chemistry students. Let's get started with today's lesson. We are going to look at lesson 11, chemical and physical changes. So if you'll get out your study guides, turn to lesson 11. We'll go ahead and get started. All right, again, we're going to be looking at chemical and physical changes today. So to start us out, we're going to look at a pizza, a good, yummy pizza. Now, when we consume pizza, there are a variety of different processes that our body uses and goes through in order to extract the vital nutrients from the pizza that our body needs in order to survive. And so let's take a moment and talk about some of those processes. So the first thing we need to do, because we usually have a large or a whole pizza, is to break it down into smaller individualized size pieces. So we usually do that by physically cutting the pizza into different parts, into smaller pieces. And when we do that, it doesn't really change the fact that it is a pizza. As we cut the pizza into smaller pieces with a knife or some kind of pizza cutter, we can still identify the fact that it's a pizza or smaller slices of pizza. And then we take that pizza and we usually put it in our mouth, right? And we begin to physically chew on it, breaking it up still into smaller pieces that are more manageable for us to swallow. While we're physically chewing those pieces of pizza, um, there are certain chemical enzymes in our saliva and so forth that are starting to chemically break down the pizza, um, and starting to get to the point where we can start extracting nutrients from it. And then we swallow the smaller pieces, and they enter our stomach, and in the stomach, we further break down the pizza into smaller pieces with our stomach acid, or chemical reactions occur to begin to break it down, some of the pizza, into smaller nutrients that we can start using. And then it goes into the small intestine where it's further chemically broken down, where the nutrients now are small enough that it can start being absorbed into our body, and we can start using those nutrients for proper health. All right. So what I'm saying is that by consuming a pizza, there are a lot of processes that occur, both physical processes and chemical processes, and we're going to kind of characterize those processes in this video. To begin with, though, I want to take a look at the term property, and specifically focus on physical properties first. Every material substance has certain ownership of properties, certain things that belong to that particular substance that makes that substance unique in what it is. So just like we usually use the term property of showing ownership, you might own a cell phone or your home or your car or something like that, because it belongs to you, it's your property. Well, there are certain properties that that are characteristic of elements or compounds or other materials that that make it unique and make them have ownership to it. So some of these are broken down into both physical and chemical properties. And the way we can think of physical properties are like, what is the color of the substance? What does it smell like? What does it taste like? How hard it is? What's its density? At what point will it melt or boil? And does it conduct electricity or not? Okay. So these are all certain specific characteristics or physical characteristics of materials that you should be able to classify. Contrast that with chemical properties. We can think of a chemical property as a specific property that is unique to a material on how it interacts or reacts or changes when it's mixed with something or when it comes in contact with something. Okay, so for instance, usually we use the term of a chemical property associated with a chemical change or a chemical reaction. An example would be when iron interacts with air, it often forms rust. And so the act of rusting is a chemical property for iron. Okay, it's a specified characteristic due to its interaction with air. Examples of chemical properties, there are some materials that are flammable, so that they burn, right? Others, rusting or tarnishing, or they might be corrosive or explosive. So all of these terms describe a substance interaction, property interaction when it comes in contact with something or something else, okay? So let's take a look at this little exercise here. What we're going to do is we have various chemical and physical properties of materials, and I just want you to quickly classify if the characteristic is considered chemical or considered a physical property. And just write a C if it's chemical or a P if it's physical. So go ahead and pause this video for a minute and then go ahead and answer that. All right, so I hope you've had enough time. So I'm just gonna run through the answers really quick. So a blue color, again, is a color, it's gotta be physical. Density is physical. Flammability, it's a chemical. Solubility, dissolving, if the substance dissolves, is actually physical. Reacts with, if you ever hear or see the term reacts with, it's gonna be a chemical. Supports combustion is chemical. Taste is, of course, physical. Melting point is physical, reacts with water. Chemical, there's that reacts with. The hardness is a physical. Boiling point is physical. Luster is how shiny an object looks. If it's dull or versus it has a lot of shiny to it, it's got a lot of luster. So that's going to be physical. Odor is going to be physical, how it smells, right? And then again, reacts with air, it's going to be chemical, okay? So I think the important thing is just to really be able to look at a characteristic property of material and just classify it as either being physical or chemical property. All right, so now what we're going to do is get into physical and chemical changes, okay? Now, when we're talking about changes here is when we alter the substance, and so it's going through a changing state. It's changing itself. What's the outcome? And there are two types of changes of materials. It's either a physical change or a chemical change that occurs. So first look at physical changes. And essentially a physical change changes the appearance of the material, but it doesn't change the actual substance. For instance, if you look at this picture here, this is a picture of gallium, the element gallium, and gallium is solid at room temperature, but if you put gallium in your hands, it will begin to melt in your hands. It's really cool. So gallium, it has this, in the solid state, these nice little crystals, as you can see, but when it melts, it forms this puddle of liquid. And so this is a physical change because it's changing the appearance of gallium, but it doesn't change the fact that it's still gallium. So whether it's a solid or whether it's a liquid, it's still gallium. So typically when we think of physical changes, it's usually like melting or boiling or freezing, evaporation of the material, cutting the material, or even dissolving the material. All right. So usually if one of these processes are occurring, melting, sorry about that. So melting or boiling, freezing the material, the substance, evaporating it. If you cut it, you're just cutting in smaller pieces, dissolving, crushing something. Those are just, it might change the appearance, but it doesn't change what it is whatsoever. I mean, if you take liquid water and you freeze it, it's still water. It doesn't change the fact that it's still water just because it's frozen, right? So those are essentially ideas of physical changes. Okay. Here's some examples. Water here, melting. Okay. Again, even though it's in the ice cube and it's in the solid form water, and when it melts, it's still water, H2O. It doesn't change. Cutting bread doesn't change the fact that it's still bread. It might be smaller slices, kind of like cutting the pizza, but it's changing its appearance or look a little bit, but it's still bread no matter what. You take a aluminum can and you crush it, it's still aluminum. It's not changing the fact what it is. Or taking the sugar, dissolving in water, the sugar is still there. It hasn't destroyed the sugar. It's just a dissolved, a homogeneous mixture, essentially, forming a solution of sugar and water. And so if I evaporated all of the water, you would still see the sugar once the water is removed. It'd still be there. Okay, so I'm not changing sugar or changing something permanently if I dissolve it. I might change what it looks like, its appearance, but it's still there. Fact is, if you ever tasted sugar water, it tastes sweet, just like sugar, because the sugar is there. Boiling water, just like we said earlier, if I boil or freeze or melt water, it's still water. It's not changing that in any shape or form. Okay. So then we get to chemical changes and the difference here. And often what we mean by a chemical change is that it's going to change into something brand new, where we're not just changing what it looks like, we are really changing its whole entire identity. It's becoming something that it wasn't before, brand new idea. Okay. Often what we will refer to a chemical change as is a chemical reaction. Okay. So when things react with one another, a chemical change has occurred. Where physical changes, we don't have reactions that occur. Okay. So what are some evidence that a chemical change has occurred? Well, typically we would see possibilities of bubbles forming, which would indicate that a gas is being formed. It might turn cloudy, which means a solid is being formed. There could be a temperature change, color change, change in smell or taste. This is a big one, like light is being produced, energy is being produced, which results in that temperature change. These give you some evidence, but usually we need more than one, because you got to be careful. Typically, we need a variety of evidence or different types of evidences to really solidify that a chemical change has occurred. All right. So, yeah, I mean, chemical changes create new things. Physical changes just change the appearance, but do not create a new substance, is what we're trying to get at here. Okay. Here's some examples of chemical changes, like wood burning. When wood burns, it creates new materials. It's no longer wood. Cooking food or cooking objects usually change really its chemical structure. So that's why it looks differently, is because we're creating something new out of its chemical structure. Here's an example of a solid being formed. All right, it usually forms this cloudy type of deal, and this cloudy solid is a great indication of chemical change. Rusting, we already looked at this earlier. When an object's rusting, tarnishing, sign of a chemical change going on here. Okay. Let's go and do this exercise here. All right, so very similar to what we did earlier, but this time we're going to be looking at processes. Are they chemical changes? Are they physical changes? If it's a physical change, just put a P. If it's a chemical change, put a C. So just pause this video for a minute and answer what's going on here, okay? All right, you should have had some time to go through and mark if you think it's a chemical process or a physical process. So let's just go to the answers. So salt dissolving in water has got to be physical. Silver tarnishing is chemical. An apple's cut is physical. It's not changing the fact that it's apple just because we're cutting it. Steam being formed, that's just physical, right? It's just a phase change. Baking soda is reacting. Again, that term reaction is chemical. Iron rust is chemical. Alcohol evaporates is physical. Ice melts is also physical. Soured milk, ooh, chemical. Definitely changes it something different. Sugar dissolving water, we've already looked at that, it's physical. Wood rotting, it's like burning in a way. It's breaking down into something new, so it's chemical. Pancakes are cooking. Cooking usually results in a chemical. Grass growing, well, if you see the grass getting larger or taller, it's still going to be grass. It's not going to change the fact that it's grass because it's getting larger or taller. So it's physical. Inflating a tire is physical. Same idea, it might be getting bigger, but it's not changing the fact that it's a tire. Digesting food is usually considered chemical, and absorption of water is going to be physical. Okay, so there we go. There we have it. Chemical and physical changes. All right, that's it for this particular video. Just really understand the difference between a chemical and physical change, and really be able to classify a process as either chemical or physical. Same thing with the properties, identify if it's a physical property or chemical property, and you're good to go, right? So that's it for now. We'll see you later. Have a really good rest of your day. And that is it.